folks, we're going to switch gears for a little bit over to nonlinear inequalities. So I can say my words, a nonlinear inequality is an inequality containing a nonlinear expression. Now, when I hear inequality, the symbols that we use for that are less than or equal to, greater than or equal to. So instead of something like a nonlinear equation like y equals x squared, you might see something like y is greater than x squared, right? Or you might see something like y is greater than or equal to x squared, or less than or equal to. And this would technically be a nonlinear inequality because this is a nonlinear term, right? It's got x to the 2, it's x squared, it's not x to the 1. It's a nonlinear expression, okay, and it's got an inequality. So you can see these four graphs right here for x squared minus 4, right? We take our toolkit function of y equals x squared and we send it 4 units down. Well, this is y is strictly greater than x squared minus 4. You can see that because it's greater than, it's got a dotted line, right? As opposed to greater than or equal to, which is the solid line. Because the equal to is the solid line, right? The shading is the greater than, the solid line is the equal to. That's why you include them both on greater than or equal to. Okay. But we've got this shading here, right? And we've got this, I should say shading with a dotted line, shading with a solid line. And it's above x squared minus 4 because we're looking for the area greater than x squared minus 4. This would have been the area less than x squared minus 4, which is over here, right? And again, strictly less than, you get the dotted line. If you want less than or equal to, add the equal to, add the solid line. All right, so we're gonna make a couple, well, not a couple, we're gonna graph a parabola, and then we're gonna show how do you determine, do you shade above or below, right? We can discern dotted or solid versus if we have a strict inequality or a greater than, less than or equal to, or a greater than or equal to. I should point to the right ones. Greater than or equal to or less than or equal to. Those get the solid lines. The strict inequalities, sometimes we refer to them, just greater than or just less than. Those get the dotted lines. All right, so let's go through this. All right, I'm going to scooch this up, and we're going to graph this nonlinear inequality. So let me get that just a little bit more closely lined up. All right, so as we look at this, the first thing I'm going to take note of is I have what we're calling a strict inequality. So because that's a strict greater than symbol, I'm ultimately going to make a dotted line. All right. If this was greater than or equal to, I would have done the solid line because the equal to is the line, or it's not technically a line, but like it is the parabola itself. All right, so let me go ahead, grab my ruler real quick. I should have prepped that before I started this video. But this is my toolkit function, right? We know what y equals x squared looks like, vertex at the origin, but I'm 1 unit up from that. So I'm gonna go ahead and sketch a graph of that. And let me get this going here. And I wanna make sure you can see it. Yeah, you can. All right, there, okay. So let me go ahead and scale it. I'll just do my favorite 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now let me go up 5 and down 5. All right, so again, I know my toolkit function's vertex is at the origin, but I'm 1 unit up, right? That plus 1 sends me 1 unit up. All right, so 0, 1, if I plug in the number 1, 1 squared plus 1 is 2. So I'm gonna have 1, 2, and by symmetry, I'm gonna have negative 1, 2. All right, if I plug in 2, 2 squared is 4, 4 plus 1 is 5. So I'm gonna go 2, 5, and then by symmetry, negative 2, 5. All right, so I can actually see my parabola in there. And if I had trouble graphing this by hand, I could always head over to my calculator, plug it into my y equals, and use my table feature. And if we haven't done that in a minute, just to remind you, right, I could head over here. Let me clear out whatever I had last, right? I could type in x squared plus 1, and then I can use my table feature, which is in blue over graph. So let me hit second table, and then you can see all of those ordered pairs, right? I had negative 2, 5, 2, 5, negative 1, 2, 1, 2, 0, 1. There they all are. But that can help me graph my parabola as well. Now I'm going to make a dotted line because this is a strict inequality. So let me put a dot. Oops. Just kind of missed. All right, now we need to figure out if we want to shade above the dotted line or below. And you might kind of be guessing it just based on the fact that this is a greater than. You might be like, you know what, Miss A, I know I'm going to shade above. And you're correct. I don't want to deny your intuition, but let's say it was a little less clear. Let's say you had a funkier looking graph and you were like, which one do I need to do? I'm gonna erase this little y equals x squared for a sec. So if you aren't sure what to do, we can use test points. And you can use any point on the graph you want. The only thing I would recommend avoiding is picking a point that was on the parabola proper. All right, so I'm gonna pick a test point, and I'm gonna do this a couple of times just so you can see that you can pick any test point. All right, and I mean any point. It doesn't have to be above, below, just pick some ordered pair that's not on the parabola. I'm gonna go ahead and I'm gonna pick, I'll pick this point. I'll pick 0, 5, right? It's not on the parabola. All right, so I'm gonna opt for 0, 5. To be clear, I could have picked 0, 4. I could have picked 0, 6. I could have picked 5, 5. I could have picked negative 5, 5. You can pick anything. The points I would avoid were 0, 1, 1, 2, negative 1, 2, 2, 5, and negative 2, 5. I would avoid those points because they're on the parabola. So I'm about to plug x being 0 and y being 5 into this inequality. And the rule is, if you get a true statement, you're going to shade over your test point. And if you get a false statement, you're going to shade away from your test point. So I'm going to do this twice because I want you to see how this could work, okay? So if I try 0, 5, if x is 0 and y is 5, right? If I start to substitute this out, I'm going to have, is it true that 5 is greater than 0 squared plus 1? All right, I'll put a little question mark over this inequality. So again, I'm plugging 5 in for y, and I'm plugging 0 in for x. All right, so let me simplify it. 0 squared is 0, 0 plus 1 is 1. Is it true that 5 is greater than 1? That is a true statement. So what we're figuring out here is that if I plug in an ordered pair, if my test point is in this region, if it's above the parabola, I'm getting true statements. So I want to shade over my test point. I want to shade the true area, right? So if you get a true statement, right, shade the region that includes your test point. Shade the region including 0, 5, or whatever your test point happens to be, okay? Now let me show you what this looks like if you get a false statement, all right? So let's try something that's not in that region, right? Because, oh, and JK, not JK, just by the way, this shading, that is my answer, all right? That's the end game answer. That includes all of the ordered pairs where your y value is greater than your x value squared plus 1. All right, let's try something that was not in the shaded region. I'm gonna try 1, negative 1. All right, so I'm gonna try this ordered pair. All right, so let's say my test point was 1, negative 1. Now, for all, just to be on the real, usually I pick the origin because I like plugging zeros in. Makes my life a little bit simpler, but let's try this one. So I wanna see, is y, right, which is negative 1, is that greater than 1 squared plus 1, right? So if I do this, right, I plugged in y being negative 1, x being 1, is it true that negative 1 is greater than, all right, what do we have here? 1 squared is 1, 1 plus 1 is 2. Is negative 1 greater than 2? That is false, right? I put that x there. That is a false statement. And if you ever get a false statement, what that means is you want to shade the region that doesn't include your point. All right, so shade region that doesn't include your test point. And in this case, again, my test point was 1, negative 1. So if this is my test point and I have two regions, either above the parabola or below, and I want to shade the region that doesn't include it, I'm going to shade above the parabola. So I get the same answer. I'm just using a different test point to get there. Right. And that's it. That's all there is to test or graphing inequalities. graph the original equation, right? If this was an equal sign, figure out what that shape of the graph would look like. Determine if you should have a solid or a dotted line, and then should you shade above or below, depending on the sign of the inequality. All right, thanks so much. Bye.